Here we're going for comparing linear, quadratic, and exponential functions and how to determine if it's linear, quadratic, or exponential, characteristics of each, and practice questions to follow. This is not the best lesson to do online, but this is all we got. So here it goes. Now, here's the part I would do in class, and it would take like 20 minutes for you to work with your partners to figure out how can you tell by looking at an equation if it's linear, if it's quadratic, or if it's exponential. Maybe you can give examples, say some words. There's a handout for you. It's posted online. Stop the video right now and figure out how can you tell by looking at a graph if it's quadratic, exponential, or linear, and how can you tell by looking at the table of values if it's each one of them. Please stop the video now, and I'll try to do the answers right after. It's really important that you think it through first, though. Answers in 3, 2, 1. An equation, I'll leave the equations for last. For a graph, this is pretty straightforward. If it's a straight line, it would be linear. Quadratic, if it's a U shape up or down, it would be quadratic. And it's not really U shape, it's got to be a parabola shape, but for now, can we keep it? If it is here going sideways, that's not a parabola. That actually would be like a plus or minus of a square root. So do not include those ones like this. An exponential, we got exponential growth, which looks flat and it goes up, always increasing. And exponential decay, which comes down and it goes towards, well, for what we saw so far, it only goes down to 0. But always increasing and always decreasing. Table of values, we check for first differences. And if the first differences are the same, then it's linear. If that's not the same, then check for second differences. If second differences are the same, it's quadratic. And for exponential, we just saw a couple of classes ago, we check the ratio of the first differences, which means that we'll always check the first differences. If that's not the same, then we have a choice. We can check for the ratios or check for second differences, and then we know it. For the equation is the one that students usually give me the wrong answer, or like they say, oh, if it's y equals mx plus b, then it's a line. Well, but what if it's like 4x plus 3y is equal to 12? That is also linear. And how can I tell? Okay, so here's the real reason. Because x is to the power of 1 and y is to the power of 1. If I can tell in expanded form that x to the power of 1 and y is to the power of 1, this will be a linear function. How can I tell if it's quadratic? Well, pretty similar. When I expand it, x should be to the power of 2, but y is to the power of 1. Okay? So that's why we have all three forms. And all three forms, you can't see the x squared. Like in vertex form, we can't see it, but we expand it, it's going to be x squared. Or on factored form, we can't see x squared, but when we expand it, we will see it into standard form. And how can you tell if it's exponential? We just talked about it too. So if variable is in or on the exponent, I'm going to say in the exponent. So like if I have something like y is equal to 2 to the power of 5, 3x minus 4. Well, where's the variable? Oh, right here. This is the exponent? Yeah, that's an exponential function. So those are easy to recognize because it's the only time that we see the input, doesn't have to be an x, could be s, t, whatever, is on the exponent. Great. Next part. Same thing. Now, are we going to take some time in class and try to fill this in, and then we just kind of check it together. So linear, is it increasing or decreasing? Are there any exceptions? Yes, there's also any exception. Quadratic and exponential. Domain, range, x-intercept, y-intercept. What do we know about each part? This is trying to figure out each part of a linear system. So I'm going to start my answers in 3, 2, 1. Okay. Linears, increasing or decreasing? Well, they're always either increasing or decreasing. Always decreasing or always increasing. There's only one exception. What is that exception? I'll get back to it in a sec so you can think it through. Quadratic, well, it's increasing and decreasing. So I got increasing and decreasing all the time. Or if it's the other way around, it's going to be decreasing and then increasing. But it's got both. And exponential functions, we know that it's always increasing, or always decreasing. Always decreasing. There's no turnaround. Did you figure out what's the exception for increasing or decreasing? A horizontal line. A horizontal line doesn't increase, it doesn't decrease. Actually, a vertical line is kind of interesting situation too, where like it doesn't go to the left or to the right, so you can't really say if it's increasing or decreasing, or if it's increasing infinitely. Not sure. That's an exception. We're not going to deal with this. Domain. Well, do all straight lines go on forever and ever? X belongs to the real numbers. Are we going to say yes? All of them do, except for one kind of line. And you can tell me in a sec. Do quadratics go on from left to right forever and ever? Yes, they do. So X belongs to the real numbers. And do exponentials go from left to right? Yep, they do. So that's pretty easy. All the domain for all the functions go from left to right forever, except for, of course, a vertical line. A vertical line will just have only one number for domain. Range. Do lines go up and down forever and ever? Yes. With one exception. And I think you could figure it out already. Do quadratics go up and down forever? Well, no. Quadratics will go depending on if it opens up or if it opens down, but the k value is going to be the maximum or the minimum, correct? So we're going to say it like this. We're going to say y belongs to the real number such that y is less than or equal to k or bigger than or equal to k. And I really should write it twice to make sure that I get both locations, but I just don't have a lot of space right now. So here is going to be smaller than the vertex, the optimal value k, and here it's going to be bigger than the vertex or the optimal value, the k value for it. Very good. And the range for exponential functions, the basic ones, we know that the lowest thing is just above 0. So this is going to be y belongs to the real numbers such that y is greater than 0. It does go up forever, but it goes low to very, very close to 0, but not quite reaching 0. Which was the exception? The horizontal line. The horizontal line has only one number for range. Okay, y-intercepts. Does this cross the... Does it have a y-intercept? Yes, it has one. Only one of them. And there's one exception. Which one's this? And does this have an y-intercept? Yes. It has one y-intercept. And does the exponential function? Yes, and it's always that y is equal to 1. The y-intercept is always 1 because b to the power 0 is equal to 1, right? So it's always going to be 1 y-intercept, and that's going to be y is equal to 1. X-intercepts. Do lines always cross the x-axis? Yes, they do. They do cross the once. Yes, there's only one time, with one exception. Oh, I forgot the exception here. So, is there any line that does not cross the y-intercept? Well, vertical lines. Unless the vertical line is actually the y-intercept of x equals 0, in which case it's got like infinite number of points for y-intercept. Same thing for x-intercept. Well, the horizontal lines doesn't cross the x-intercept, the x-axis, unless it is actually the x-axis, and in that case every single point would be an x-intercept, but that's just an exception. We kind of mentioned it for fun. So what about quadratics? Yeah, quadratics can have well, two x-intercepts, or they can have one. Just touch, or they can have none. And what about exponential functions? Well, that's the one that drives me crazy. This one will go closer and closer to 0, but never reaching it. So there's no x-intercept for the basic exponential function. Okay, this is only for the basic exponential function. When we start putting modifications on it, I'll make it go up, I'll make it go down, so therefore that would be the different story. But for the basic one, there's none of them. Does it have a max or a min? Well, the lines go up forever and ever, and no, it doesn't have a maximum nor a minimum, because it keeps on going up or keeps on going down. Is there an exception for this? Yes, there's one exception. You can tell me about it later. Quadratics, do they have a max or a min? Yes, because it's got like, if it opens up, have a max. So if it opens down, it has a max. If it opens up, it's got a min. Right? Now that's determined by the a value. Very good. And what about exponential function? Does it have a max? Well, no, they go up kind of like forever. Does it have a min? I would be tempted to say 0 is the minimum, but it doesn't quite reach 0. And if it doesn't reach 0 and it keeps on going lower and lower and lower and lower for infinity and beyond, there is no max or min, even though it goes closer and closer to 0. What's the exception for the linear function? Which one doesn't have a max or a min? The horizontal line is kind of like the exception, because it only has one value for y. So that one value is the maximum and it is also the minimum.